Hi, everyone. My name is Nick, and I'm a product manager here at OpenMind. I'm here today to talk to you about science and how we might use our private AI tools to help solve access to the world's scientific information. But first, a quick recap. OpenMind's mission is to align and incentivize all institutions to only serve the best interests of humanity. To accomplish this, we're building infrastructure that changes the flow of information to enforce this alignment and create novel incentives. One of the biggest institutions that's near and dear to my heart is the institution of scientific research, the means by which we learn about the world that we live in. Science is our source of truth. The scientific method has become one of humanity's most successful and fundamental sources of truth, and our chief driver of innovation and prosperity. However, it has a core constraint in that it relies on the ability to observe the subject we want to understand. Specifically, the more personal and valuable the hypothesis, the more personal and valuable the data it requires. But due to broken incentives that we'll get into, personal and valuable data is the least available kind of information. So what are these broken incentives that prevent scientific data sharing? Well, there's a positive one and there's a negative one. The broken positive incentive is that every institution you share data with instantly becomes a competitor for uses of that data. Think about future research on the data or future products and services. There's also a prohibitive negative incentive, which is that sharing data brings with it significant legal and ethical risks. As a result, the world's most valuable and sensitive information gets locked away in data silos at the expense of our ability to make scientific progress. What could we do if data sharing incentives were fixed, however? Why should we pursue this as a problem? Well, the following questions really can't be answered without access to personal and valuable data. For example, are we all getting less sleep than we did in 1960 due to blue light from smartphones and staying up scrolling? And how is that affecting our driving and our learning later on? Does eating kale really extend your life expectancy by 20%? I have seen studies online that claim this result. But then when I go and I read the actual research paper, I see a sample size of only 50 people in the experiment arm and 50 people in control. And that's really not enough to claim statistical significance of that 20% difference. Also, what's the impact of teaching financial literacy in high school on long-term wealth and security? This is something that I strongly believe in and I care a lot about, but I don't have a lot of data to actually back up the results of doing this. Finally, to people who focus on experience and travel and family life, do they live happier and more fulfilling lives than those who try to strike it rich or climb the corporate ladder? There's a huge backlog of these questions. And the really important point here is that we can't answer these questions without access to personal and valuable data. So what is the solution to this? Well, we think it's data science without access. If we can make it possible to learn from data that you don't get access to, we will fix these broken incentives and provide two things: more answers for society to all the questions that you saw earlier and a number of others, and less privacy leakage. So if we do this in the right way, we can actually extract these insights and answers without sacrificing personal privacy. Here's the pitch. We want to build infrastructure for remote data science. So specifically, we want to allow you to extract insights, train models, and evaluate results on data that you don't need access to at all using remote execution. So to really make this concrete, imagine you just wake up on a Sunday morning. You flip open your laptop. You can then train a model on cancer data from 1,000 different hospitals. That's very powerful, and this will take us a long time to actually build to that end vision. So how do we get started here? Well, before we have massive open networks for data, we first need to be able to let just two people, one with data, a data owner, and the other with data science expertise, perhaps a machine learning engineer or a PhD student, do an experiment without revealing the data itself. This is our primitive. We call this OpenMined Duet. This is our minimum viable product, or MVP, for OpenMined. And what Duet does is enables remote execution and permissioning of tensor requests from a data scientist notebook to a data owner's private data with just one simple Python notebook. This is really important because this allows OpenMind to provide immediate value to our users, data scientists, and data owners, and get quick feedback on what features and privacy-first machine learning capabilities we should build next. So here's the MVP in action. So we have two characters here. One, we have Shaista, who works at Boston General Hospital on the left. She's the data owner. And on the right, we have Delanche, who is a PhD student at Oxford. He is, in this case, the data scientist. So we have two Python notebooks going on concurrently. And notice that they're in different geographical locations and in different professions. On the left, Shaista will create a duet. She'll create it attached to an object we call the grid, which will come important later. This will be our overall peer-to-peer grid of all these private data networks that we have. She'll create a Duet object, and out of this Duet object, she'll get a unique identifier, which she'll pass to Delanche over some kind of chat or verbally. They'll be on some kind of video call for this initial MVP. Delanche then, on the right-hand side, takes that ID and connects to the Duet itself. Now we go back to Shaista. She's going to host some data. So she'll create two tensors. One will be a data tensor that is, she'll tag as with some sensible string like data. And the other will be the target tensor, which she'll tag with another sensible string like target. And then she'll host both of these, both the data and the target on the Duet itself. So this is where the important part comes in. If we go back to the launch, what he's going to do is search the Duet for anything tagged as data. And this doesn't return to him the actual data. That's the really important part here. It returns to him a pointer to that data. Same thing with target. Now what happens is Launch is going to create a model, in this case, a linear regression, and he's going to train the data pointer and the target pointer. And then he can use that model to predict future instances of data. So the key point here is he has just trained a machine learning model on data that he never saw and never needed to see. He's just using the pointers to that data, using remote execution. So the actual execution is happening on Shaista's side. If at any point the launch wants to sample some of the data or sample the results, he can call .get, but that adds to a request pool that Shaista then has to approve each instance of. So the key point here is that Shaista has to approve any instance of the launch seeing any of the data. But the launch can still extract all the insights and train models on data that he can't see. So this is our MVP, and this is how we think it'll work in action. So what are all the next steps we need to do past MVP to the end vision I talked about earlier, where you can just wake up and train data on a number of different hospitals' information? You'll see in the top left, we have the Duet MVP. And the immediate step here is to release this and get your feedback, because this whole roadmap is very much rough and living. We'll need to redesign it in reaction to your feedback. We'll need to figure out which privacy-first AI capabilities we should build. But here are some of the ones we think will be important to enabling a fully interoperable marketplace for science. One would be a data registry. So in the previous example with Duet, Shaista in the launch, they had to know each other. They had to know that, the launch was a capable PhD student, and the launch had to know that Shaista had data that he was interested in. So in the data registry world, you could instead just go to a website and search for, people who own data that have cancer implications or that have sleep examples in their training set. You can use this instead of having to know the individual people. After the data registry, we think what would also be really important is a way to do offline training and evaluation. So another limitation of the Duet MVP is that you have to be on the same video conference call. Shaista has to approve any requests that the launch makes. So with offline training and evaluation, we can provide a way such that the launch can still do all of his training and evaluation in an offline way without having to be on a concurrent call. After that, there's the next really big step here. And this is all about trying to fix broken incentives and ensure that incentives work correctly for science, which is rev share, reputation, and billing. In particular, rev share and billing are all about making sure people get paid, because that's the strongest incentive that we have. So for this one, we want to make sure that there's a way for data owners to get paid for hosting a peer-to-peer connection on the grid, and for data scientists to get paid for their expertise. Reputation is really important too. So on the data scientist side, we want to have ways such that data owners and other people can establish the credibility of data scientists and how good of data scientists they are, what types of inferences they draw, but more importantly, making sure that they don't draw faulty correlations instead of causations and put out claims that are misleading at best. On the data owner side, we want reputation to actually signify, how do I know if this data is actually good? How do I know if the rows have been vetted? How do I know if they include things like fair and diverse representation, if they involve people? So this reputation angle will be really, really important for helping to align incentives here. Next, we need some kind of open data network. So this is really a step above the data registry, where instead of having to search for people that own the data, you can just search the data itself. Imagine you could, of course, wake up on your Sunday morning, you grab your cup of coffee, and then you could search for a string like cancer, and it would just find the 1,000 or so hospitals that are on the grid that can host this data. And then you can connect remotely to each of them and run inferences. All of this, and all of your feature ideas too, of course, will lead to what we think would be a fully interoperable marketplace for science and help accelerate progress in that field by extracting insights on data that you don't need to see in the first place. If all of this sounds exciting to you, we have a couple of ways for you to get involved. One is, of course, our GitHub. We're always looking for people to donate their time and energy into contributing to issues that we have. We have a Slack where you can join to get involved. You can meet other people working in the privacy field. You can join channels of how to get started easily. You can join more community groups if you're not so much an engineer and just want to help out in other ways. You can also donate. We are a nonprofit, so we accept donations. You can go to this link by clicking here to find out. And then we also have a newsletter. This is where you can find out about all of our updates if you don't want to get super involved in the details, but just want to know the things that we're working on. And finally, I definitely encourage you to come to our tutorial session to see Duet in action. We're going to have a tutorial. We're going to show you how this works. It'll be an expansion of the earlier slide you saw with Shaista in the launch. And you can find out when that will happen and how to get involved at the agenda link here. So overall, what we really want you to do is to be inspired by this and use the Duet MVP when it comes out, because we need your feedback to inform what features we build next. And your feedback will be really, really critical. It will help us not only inform what features we should build next, but inform the entire roadmap of how we can best all work together to help accelerate science. Thank you.